This is an update on the solar installation on Hummingbird Key. As you can see, the panels are all installed. There's 4 rows, there's 4 arrays. You have array A is the farthest, A, B, C, and D. Each array has subarrays. There's 4 subarrays, and each subarray has 5 strings of 3 panels in series. So what you have is each subarray has a combiner box. A combiner box combines 15 panels and strings of 3. So you have, effectively, you have 5 strings of 3 going into this box, which combines those to a single output for my safety switch. This safety switch, from the output of this, actually goes back to a charge controller in the equipment room. So that's all the dressing of the wires became actually very neat. It's very key to dress these so that there's no abrasive edges and things of that nature. But when we go down there, I'll show you. So this is array D. This is D1. There's 4. So there's array D. This is D1. That's D2, D3, and D4 as you go down. So you have 4 arrays. A is the farthest. And the reason I made A, that one, this one D, because I have 2 more rows I can put in. So it would be E and F. Rows E and F would be right here if we expand it. When you look in here now, these are the wires. So each string that you have 5. There's 1, 2, 3, 4, and 5, and basically they're all labeled. So you have A4, which is this is subarray 4. So that's A4 S1. So basically it's array A, subarray 4, series 1. So that wire right there goes to the first 3 panels in this subarray. So you can isolate it right down to exactly what, if there was a problem, which there's not going to be because I very methodically put everything together. Each of my subarrays, which there are 16, 2 subarrays come through 1 conduit. So I have 18 conduits here. There's 4 for future expansion, but there are 8 conduits, each one handling 2 subarrays. So each array has 2 conduits coming to this room, which will go to our FM80 charge controller panels. Wires will come in, 2-aught wire will come in from my combiner, actually my safety switch at each subarray, come through my conduits and loop down and actually tie into my input breakers for my FM80s. Each FM80 input breaker, you have input 1, FM80 input 2, 3, 4, and so on. Each one is labeled for a subarray. So FM80 number 1 in cabinet 1 will be subarray A1, which would come through the conduit right out to the safety switch disconnect out in the field. From there, we actually have our ladder racks that will bring our double 4-aught cables to our main DC bus. So each cabinet has 2 plus 48 volt 4-aught cables and 2 negative returns of 4-aught coming to our buses. Those have already been wired. From there, we're actually going to put our cable troughs up on the wall, tie in our DC bus, main DC bus, into our load centers for our radiant inverters, which there are 4, for a total of 32 kilowatts. The next phase of this project will be to run our RO, which is a reversed osmosis to make drinking water on the island, fresh water. We have the equipment. What we want to do is run them directly from our 3-phase inverters. These are out back 3-phase inverters, to run our RO directly from the sun during the day while the sun is out, because our array is actually 60,000 watts, and we should be able to run our RO all day, making water effectively for free. It's a future phase. This is our output to our island is here. We have our system bypass safety switch, and this is our main generator input from our panel to our inverters, and this will actually be the feed out to the island. The output from the inverters go through this main circuit breaker panel, which each inverter will have its own 50 amp breaker, which will feed into this safety switch, which will actually be selected either bypass from the generator directly to the key or to inverter, which would be drawing power off of our stored energy.